Welcome back. In our previous video, we examined the logic behind group by. In this video, we'll work with a couple of queries applied on the IMDb database to understand better how group by queries work. Let's start with our first example. We want to see the number of movies that were released in each year. How are we going to do that? First, we need the information in the movies table. So let's take a look. Select star from movies. You see now the individual movies, but what we want to do is we want to see how many movies were released in each of the years that we see here. How many movies were released in year 2000, 2002, 1971, 1913, and so on. To achieve this, we want to create a group for each year and then count how many movies are released in each year by counting the number of rows in each group. Let's try to visualize first how this grouping process works. I typically like to visualize the groups by using the order by clause before doing the group by. In this case, I'm going to order by year, and so I'm going to the end of the query and I add an order by year. We execute now the query, and what the ordering process is doing, it creates visually the groups by putting all the entries for a group next to each other. So for example, let's take a look at the results. We have one group with the movies that were released in year 1888. You see we have two lines in there. We have the next group that has the three movies that were released in year 1890. That's the other group. We have another group for year 1891 with 6 movies, right? Here is yet another group. Another one for year 1892 and so on. These are our groups. You can continue if you scroll down. What we want to do next is take these groups, which are defined effectively by the values of the year attribute, and count for each of these groups how many rows do we have. So I'm going now to switch, and instead of using just order by, I'm going to add a group by. So I'm adding before the order by, group by year. Once we added the group by part, this part creates the groups. Next, we're going to go to the select part and modify it to show each group and the number of entries for each group. So now we add select year, which is going to show the group value. We're going to continue and add the aggregate for the group. So we add comma count star as num underscore movies. So the count star aggregate counts how many movies appear in each of the groups. We execute and you'll see that we have 2 movies for year 1888, 3 movies for year 1890, 6 movies for year 1891, 9 movies for year 1892, 2 movies for year 1893, and so on. This is how we calculate the number of movies in the database. Select year, comma count star as number of movies, from movies, group by year, and then order by year. Let's do another query. We're going again to focus on movies, but now instead of counting the movies that were released in each year, we want to compute the average rating for the movies that were released in each year. So let's start. We have our query. We'll start with our existing query, the select year, comma count star as number of movies, and we're going to modify it. Instead of doing just the count aggregate, we're going to do now the average aggregate, and we're going to average the values that appear in the rank attribute. Let's call this the average rating for the movie. So we go select year, comma AVG, which is the aggregate for average, within parentheses rank, which is the attribute that we are aggregating, as AVG underscore rating. We execute the query. You'll see that we get back quite a few of decimal points when we are reporting the average rating for each year. So let's try to beautify a little bit the result by keeping, let's say, 2 decimal points. I'm going to use the round function, which I put around the aggregate. So I put round, parentheses, I keep the aggregate inside, then comma 2, close parentheses, as, again, average rating. We execute, and you can get back the result. In our query, we have replaced the count star aggregate with the average rank aggregate. In reality, there is no reason to delete the count star aggregate, and actually we can keep it together with average so that we can compute both aggregates at the same time. So let me go back and add back the count star. So I'm going to select statement and I add count star as num movies. And now notice that we have the number of movies and the average rating for these movies combined. Let's take a look at the results. For year 1888, we have a null average rating and 2 movies. Year 1890, we have 7.3 average rating and 3 movies. Year 1891, 3.68 and 6 movies, and so on. Notice one thing though, based on the results of the query, we may assume that the average that we see is calculated across all the movies in that year. However, this is not strictly correct. Take, for example, year 1888. We have a null average rating, despite the fact that we have 2 movies in that year. Why do we have a null? Because if you go back to the results, you will see that none of these 2 movies that were released in year 1888 had any rating. For year 1890, we have an average rating of 7.3, and we see it is for 3 movies. However, we don't know how many of these 3 movies actually contribute to the rating. Let's go and take a look at the raw data. So execute the standard select star from movies, order by year. You'll see that for year 1888, none of these 2 movies have a rating. For year 1890, you will see that we have 3 movies, but only one of them has a rating, and the rating is 7.3. The other 2 don't have a rating, and therefore the average that we see is calculated based on just one single rating. Why bring this up? Because it's a good opportunity now to see the difference between the count attribute aggregate versus the count star aggregate. And we're going to use that to calculate how many movies in each year have a rating. Again, remember the difference between count star and count attribute. The count attribute counts for each group how many lines in this group have a non-null value for that attribute. Therefore, we want to count the movies that have a non-null value for rank. So we go and we add count rank as rated movies. So now the new query has 3 aggregate functions computed for each year. Count star reports the total number of movies for that year. Count rank reports the number of movies with a non-null value for rank for that year. And average rank computes the average rating for the movies that were released in that year. So if you take a look at the results, 2 movies in year 1888, none of them is rated, and therefore the average rating is null. 3 movies in year 1890, 1 of them is rated, and the average for this one movie is 7.3. 6 movies in year 1891, all of them rated, average 3.68, and so on. Now, let's do one final modification of our query, and let's try to add a few more aggregates. We have the average rating. Let's try to add also the numeric aggregate functions of minimum, maximum, and standard deviation to calculate the corresponding aggregates for the rank. So we add max rank as max rating, min rank as min rating, around stdev rank, 2 as stddev rating. If you execute the query now, you will see that we have the additional aggregate statistics for each year. And in addition to the number of movies, number of rated movies, and average rating, we also now see the minimum, maximum, and standard deviation for the rank attribute for that particular year. In this session, we examined how we can compute aggregate statistics for the movies broken down on a year-by-year basis. We started with just a simple query that was counting the number of movies per year, and then we slowly expanded the query with more aggregates, showing that we can calculate multiple aggregation functions at the same time for the same group. In the next couple of videos, we'll be working on more examples showing how we can use group by with different tables in our database. Until then, play around and practice. See you next time.